Welcome again to Quick Bytes, a series of brief videos on leveraging the Texas open and closed data portals. I'm Stacy Lewis, Data Portal Administrator. In this video, I'm excited to talk about geolocation and data sets. Geolocation is what powers map visualizations on the platforms. Without this information being included and set up properly within a data set, the great features of mapping, like easily creating heat maps or layered maps, are just not possible. Being able to map a data set is one of the most requested functions that I hear from data consumers. Fortunately, this is easy to do as long as your data set contains address information, as the platform will geocode your data based on your specifications. Before we get into the how of geocoding, let's look at the three types of geolocation data that is possible on the platform, and I'll show a few examples. These data types are point, line, and polygon. The most common is point data. This is a discrete data element that represents a singular record of a data set as simple XY coordinates, and it describes the latitude and the longitude. Here you can see a multi-point map created using a data set from the Texas Commission on Environmental Quality, which identifies storage tanks. Each point in this data set, visualized on this map, represents the location of one storage tank. You may come across the term centroid. This is a type of point data that gives the average position within an area or its geometric center. This could be within a city, zip code, or county, as in this example, which shows county centroids as the points. The second geolocation data type is a line, which represents a connection between 2 points. A multi-line data type displays a path when it's visualized on a map, like this freshwater-saltwater boundary map. Finally, a polygon represents an area with a defined perimeter, such as an individual state. Multi-polygons are useful in making layered maps when you want to show boundaries. Here's an example of a map visualization that combines point data, so summer meal sites, shown as the colored dots, as the first layer, with multi-polygon data for Texas counties, outlined in white, as the second layer. Another benefit of having a geolocation column in your dataset is the ability to build aggregated maps, which displays data totaled by polygon. There are several base maps to use for aggregation on the Open Data Portal, including Texas counties, such as the example you see here, and coming soon, zip codes to use as a map layer. Multi-line and multi-polygon datasets are created by easily uploading the dataset as usual. This is usually done as a .zip or zip shapefile. Now, the term shapefile is quite common, but the format consists of a collection of files. The .zip file contains at least 3 mandatory file types listed here. If your data set has point data, like mine does, maybe it's a full address, maybe you just have the city or you just have the zip code, you will need to create a georeference column when uploading your data set. Fortunately, the geocoder does the hard work for you. I'm going to show you how this feature works, but please note that I'm using a very small data set for demo purposes, and processing will take more time for larger data sets. I've uploaded my data, as you can see here. I've ensured that my data column types are correct, and I've formatted a few columns so that my data is clean and it's now ready to go. From here, I'm going to select Add Georeference from the menu, and for each address component, I need to select the column with the corresponding information. Now I'm presented with 3 options here: latitude and longitude. If I did have that information within my data set, I could choose the columns that represented that and move forward with my mapping. My next option is to have my address separated out into columns. And really, this is the best option because this offers more flexibility within mapping. I may just want to map to my specific city. From here, I could choose city, and then my other columns would be none. And I could move forward with my mapping from here. Now, one point to mention, if you only have the zip code, either in your data set, or if you just wanted to map to the zip code and choose that where your other points would be none, this is only going to plot to the zip code centroid location. Now within my data set, I do have a combined location, so I'm going to show you how that works. I'm going to choose the column for the full address, which in my case was property location. And the next thing I need to do is choose how errors are handled. Right now, skip row is selected, and this is going to treat the cell as an error, and the entire row is going to be removed from the data set. In my case, I'd rather that particular cell be null, and instead the row will be imported, but it just won't have a georeference column value. From here, I need to add a new display name, and the next thing I need to do is run geocoder. But how do I know that this is going to be accurate? Well, you can select the map icon here and preview your data on a map. Now, most of my sample data is located in California. I did add one Texas address so I can see that my data is mapping in the correct areas. I'm going to choose to add my column, and now I can check to see. Here is my test location column, my geocoded location. I can just click done, edit any metadata that I need to finalize, and then publish my data set. Once my data set is published, I can then start making maps. As always, please don't hesitate to contact me with any questions or suggestions for future quick byte videos. Thanks so much for watching, and we'll see you next time.